Now, in this small video, I tried to prepare a topic on Miller sweep circuit. In the last class, we have discussed about bootstrap sweep circuit through using Zoom. Now, I had tried this PPT video. In this, we are going to discuss about a Miller sweep circuit. So, as you can see on the screen, first we should have some introduction about this Miller sweep circuit. What is a Miller sweep circuit and how it is different from a bootstrap sweep circuit. So, as far as this Miller sweep circuit is been concerned, it is just similar to your bootstrap sweep circuit. The same principle is involved in this Miller sweep circuit also. What is that principle is a constant current is need to be generated, and this current is being passed through a capacitor for getting a ramp voltage. So here also the same thing is done. We will be generating one constant current, and that current is being passed through a capacitor for generating a ramp voltage. The difference what we have between a Miller sweep circuit and a bootstrap sweep circuit is in a bootstrap sweep circuit, a positive ramp is being generated, but in a Miller sweep circuit, a negative ramp is being generated. So you can see in the next slide, I'll show you the circuit diagram of this. So you can observe the circuit diagram now. So in this circuit diagram, you can see the transistor Q1 is an on-off switch and the transistor Q2 is a high gain amplifier. The input is a pulse or a rectangular wave. And now coming to this operation of this, now we'll start your operation. You can observe the waveforms also in the next slide in this. Okay, I'll show you, I will explain you this circuit diagram first, then we'll go to the waveform. So first, the input Vi is, when the input is being positive, then Q1 becomes on and it goes into saturation. So the potential of point A becomes 0 because Vc sat is equivalent to 0. Therefore, Va is equal to Vc sat, which is equal to 0. Then the transistor Q2 remains off since it is not going to get any required necessary base drive. Now the potential of point A will remain at Vcc. So therefore, the voltage across the capacitor Cs is Vcc. That is, Vs is equal to Vcc. When the input signal Vi goes negative, then Q1 cannot conduct. When this Q1 is off, the potential of point A will rise to Vcc. But because of the presence of the capacitor Cs, the voltage across point A is not going to increase instantaneously because of the presence of the capacitor Cs. It is going to increase very gradually. Okay, so now when the voltage across the point A, that is Va, is increasing gradually, the voltage across the capacitor starts falling gradually. With Q1 off and the potential of point A is increasing, Q2 becomes on. The potential of point B now starts decreasing to 0. But because of the presence of the capacitor Cs, the voltage across the point B, that is Vb, will not come down very instantaneously, but it is going to come down very gradually. So as Va is increasing gradually, simultaneously Vb is decreasing gradually. Therefore, the voltage across the capacitor starts decreasing very slowly. So the result is that the Cs is going to discharge, the capacitor Cs is going to discharge linearly. Thus, we can observe that the voltage Vs across the capacitor Cs is a decreasing, that is a negative going ramp. I'll show you in the waveform. You can see in the waveform now, initially the voltage across the capacitor was Vcc, which is available on that. Now after that, the voltage has started decreasing. That's why in a Miller sweep circuit, the output voltage is a negative going ramp. This is the difference what we have between a Miller and a bootstrap sweep circuit. All these points have been discussed in the slides available there. You can observe what I have told you, that is been written there in the remaining slides. So you can observe that what is been available, just I have made them into points and given all those in that. So the main thing is the waveforms and the circuit diagram. This circuit diagram is a Miller sweep circuit diagram. It is just similar to your bootstrap. The difference what we have between bootstrap and Miller is the ramp voltage which is being generated. In a bootstrap, a positive ramp is being generated, but in a Miller, a negative ramp is being generated. So thank you very much for listening to me. That's it in this small video.